Boom, boom, boom. Test 1, 2, test 1, 2. Is there some sound? Hello, hello. Show me some sound. And some video. Hello. I don't see. Okay, now I see something. Is there sound? Hello, hello. 1, 2, 1, 2. I don't see. Okay, now I see something. Is there sound? Hello, hello. Sounds good. Perfect. Then let's make this one big and then hello. I think this one I should also see. Good, good. Then let's continue with our 2D platforming game. So first of all, sorry because I did not stream on Friday and also not yesterday on Saturday. The reason was it was quite a busy week for me with real life stuff. And I always came home late in the evening. And then I simply was too tired to do some streaming sessions. That's why I skipped them. But the good part is that today we have a lot of time. So it might be a little bit of a longer stream. And also tomorrow there's a public holiday in Austria. So there will also be another stream. And first of all, happy Easter to all Christians out there which are celebrating the Easter holidays today. And to all the ones which are hating Christians, I just wish you a happy Sunday. Good. Where did we stop last time? Okay, first of all, here there are always new versions of this mind map application, it seems, which is good if something gets regular updates, but also bad because that means there are usually bugs which are getting fixed. And I prefer if there are not weekly updates. I'm fine with it if it's 2 or 3 times or 4 times a year, but not every week. That's a little bit crazy, but whatever, it does not take a lot of time. So first of all, for today, we want to implement the second enemy. So this stone enemy, which is crushing our player, hopefully. So there we need to implement something. And also some invulnerability effect. So when we take damage, then currently we don't take damage for 2 seconds or something like that. There's some invulnerability time, and that should somehow be indicated. And the easiest way would be if we add some blink effect to our sprite. So that is what we are going to implement today. And the second thing, let's see, what did we do last time? I think last time we optimized the user interface a little bit, or I showed you that, how to make it a little sharper with the texture filtering, use the nearest instead of the linear filtering. Then we added some additional logic to have game objects behind the background. What is that? Eingabeumschaltung. Not now. Okay, so that game objects can be in the background. So this saw, for example, is in the background. Our player is in the normal layer or in the middle, let's say, of all the available layers. And then we have, I think this saw actually is in the foreground. And yeah, so we have this damage stuff already going on. And also the saws are no longer blocking us. Those are just sensors. And we will optimize that a little bit in the future. So play some hurt animation of the player when we take damage. And my idea would also to push him a little bit back, maybe with a force in box 2D when he's taking some damage. But that's something for the future, for some finalization stuff. Today, we want to add an enemy, a thwomp. I don't know how it's correctly pronounced or what would be a good description for that. I just used thwomp, crazy word, from Super Mario. The stone guys which are crushing Mario, they are usually coming from the top, but I think in some Mario games they can also go left to right. And that is what we want to introduce. So let's see, assets, and there should be, I I think that's the zip archive. We no longer need that. I can remove that. Pixel adventure, and there should be an angry pig. No background. No. What would it be? Fat bird, ghost, items. What? There are items. The different fruits and stuffs like that. Okay. Then we have main character, menu. Cool. There would be even some user interface stuff in this asset pack, which is nice. Then other. That's just some weird stuff. Plant. I don't think it's a plant. No, it's not a plant. Radish. No. Rocks. Maybe it's rocks. No, it's also not a rock. Skull. Slime, snail, terrain, traps. Maybe it's a trap. A block. No. A falling platform. No. Rock head. Okay, that's the one that we are going to need. Hello, cop the fish. I'm looking for the correct graphic for our second enemy in the game. And I'm thinking, what do we need? So bottom hit. Not sure if we need those. I think at least in my idea, we just need the idle animation of this stone head or rock head. Then we need like a moving animation. Let's see, idle is eyes opened. I would actually prefer it the other way around. So I would say the idle animation would need to check that, but maybe the eyes closed. Then when you get close to that guy, then he opens up his eyes. And finally, when he's moving, he has everything open. So eyes open and this mouth to the bottom. I think that would be more like the move animation. And then he's moving left, right, and at some point hitting the player. So anyway, whoops, that was too quick. Anyway, we need those two graphics here, I would say. And that's our starting point, as always, for a new enemy. And there we have an object folder, and then let's call that. Do we also call him Rockhead? Yes, let's call him Rockhead with a minus. And then we need our image magic tool again. There we just need to crop one graphic, which would be the Blink 182. No, it's called Blink 4242. So the graphic is 42 by 42. And not even sure. Let's call that idle. But it's not actually the idle animation. It's something else. Let's see. So my idea would be, let's see. So the one with the closed eyes. So this one would be really the idle animation. That one here would be something like did we call it run? Just to be consistent. Yes. So that one would be run. And then we have an animation to, I don't know how we want to call that, maybe aggro or something. So when you get in range, at least in Warcraft 3, it was called like that. So the aggro range, so the range where neutral creeps got aggressive. And when you are within that range, then they are going to attack you. So maybe that should be like the aggro animation. So, yeah, let's call it aggro animation. So aggro 00, aggro 01, and aggro 02. So that would be my idea. Idle is nothing, so there is just a static. Run is also static, but he's actually moving left or right. And this is when he gets almost activated. So something like that. Yeah, I think that's a good starting point. So let's add that to our object texture atlas. So packet. So we have here the aggro 1, idle 0, aggro 0, run, and aggro 2. Looks good. Then we also need one graphic for the tiled object editor. So there I would just say the idle 0, graphic is the one that we use in the tiled editor. So there we also have maps. No, it's not there. Graphics, object, I think it's this one. And that one we will call Rockhead. And let's see. So that's already, I think, good enough. So let's take, first of all, our player and move him to the beginning. By the way, there I remember something. So what we are currently missing, and which is in my opinion not very nice, is that we can actually go out of the map, which is pretty bad, I would say. So there, what I normally do is just I add some box 2D chains around the map boundary so that you cannot go off screen. But we are currently missing that, but we should add that. So that's a small feature. So I will add that to this day here. Add map boundary fixture or body to avoid player moving out of bounds. And here I also had an idea. So maybe the bottom edge is a little bit below the actual map. And when the player gets in contact with that, then he simply dies and respawns or something like that. Good. So I think we should be able here to we need to actually manually add that, right? I forgot the process here, but I think we need to manually add an image. Okay. How does that work? Because that is 42 by 42. We used here, how was that called? A collection of image or something. So it seems like that supports images of different size, which is actually great in our case here. Okay, so first things first, we need a shape for the collision of that little boy here. So we will give him, I would say, that's pretty obviously a rectangle. And let's make it like this. And that one had, how did we call that? We actually have a class for that. Wow, I didn't work on that project for a couple of days and I forgot almost everything. So we have a class here. Then I can say a density. It should be a higher density than the player to be able to move him around. So here I chose 100. So let's also pick here 100. Friction should be maybe 1. I don't know what happens if the player has a friction of 0 and that one has 1, that he could stick to it. No, let's not deal with that stuff. So with this wall jumping things and so on. So let's say it's 0. Then is it a sensor? Actually, no. Is it a chain? Maybe. No, I think it should not be a chain because then there is no collision or there was a problem with the two chain fixtures are not colliding with each other. So let's not make that a chain. But the user data should be, I think, hitbox. I think we called it like that. Yes. Okay, so that should already work with our framework that we have written. Then the next thing would be that we give this also an entity definition. And this one is a kinematic body. The damage is 1 as well. But does that actually maybe kill the player? Nah, let's say 1. So you can survive that if he squashes you. if you have enough life left, then it's not a player, it's not a camera focus entity. The game object is that one we are currently missing. So we need to add something to our game object enum. There we now also have a rocket. Which we also need to add in here to our game object enumeration. Rocket, like this. So now we can give him this. Then has animation. Yes. Has a state. That one here we might now need to change because I thought of two solutions how we could solve that. One solution would be that we really add the AI behavior tree stuff to our game, which means that the state that we currently implemented would be independent to what an entity can do. And with a behavior tree, that would be the second part, we could then write way more complex AI stuff. So usually you would most likely need that for a more complex game, like for example an RTS game, where you have your troops and maybe they follow a certain player, and if they get attacked, they automatically hide behind some obstacles or something or shelter, and then they might peek and shoot something. So where you have more advanced AI. Our platformer game, I guess, does not have very complex AI. So we will stick with state management. I think that should be good enough for our scenario. And what we could do here, instead of setting a state with a flag, we could set an initial state. And for the player and the saw, it would be the state machine that we currently have. So this standard behavior. And for the rocket, we will have a separate state machine. I think we will go with that. So that one we need to adapt. Then track, he does not need that. Jump height, he also does not need to jump. Life, can you destroy a rocket? No, I would say no, does not have a life. Speed is maybe faster than the player, so maybe 12. And the time to reach that, so he should maybe slowly accelerate to that maximum, would be maybe something like 2 seconds. Here it's 4.5 seconds, so let's give that here 3 seconds. And that's it. And finally, in our map here, we should now be able to place a swamp where I want to place one up there. That's our test. I call it rocket now. So this is our test rocket to check if he can crush the player below. And we also would need another one where we can check the left and right movement. For that, I would say let's make the map again a little bit bigger. Yeah. Maybe 10 more tiles for some testing stuff. And let's also move it to the right. Okay, like this. So now we would be able to also place a swamp somewhere here. Maybe on the platform that we can test it. So maybe here, there we add some platform to it. And then when we jump up, he should push us away down the platform. That would be the idea. So let's modify our map here quickly. What kind of presents did you get today if you are celebrating Easter, by the way? I would be interested. I got nothing because I did not went to the party with my family. The reason is today in the morning I really did not feel that well, and still I have a little bit of pain in my throat. And I think I have a little bit of fever because I'm super hot all the time and sweating, but it's not so bad that I cannot do something. And I slept already quite a lot today. So that's why I wanted to do something productive and started the stream now. But yeah, not feeling 100% well. I am missing again this rectangular selection thingy. Ah, here it is. Okay, now I want to cut off these pieces here and place them over there. And I also want to copy and paste those little thingies here. Okay, and finally I want to have this. Oops, which layer is that? That's the decoration layer. So I want to have this one here as well. Then that one here, maybe somewhere here. And we also need then the middle part. Okay, that's it, right? So this one should be here on top of this platform, and this guy should be, for example, here, and he should then squash the player below. So that would be the idea. Yeah, let's start with that. Let's see if these enemies are already visible in our game, if we did everything correctly, or if we forgot something. Obviously, we forgot something. Array is empty. Which array? What's the problem? Tiled service. Ah, because we always load here the idle animation, if I'm not mistaken. Yes. But our Womp should have, or our Rocket should have an idle animation. Yes, idle 0. Why is that not loaded? Maybe, let me check. So we get here the atlas of the game objects, and what is our key? It's object ID, atlas key. Ah, okay, that one is not correct because we don't have an underscore, we actually have a minus, so the atlas key would also be lowercase, and then replace the minus, the underscore with the minus character. That would be the correct key. Okay. I see here a rocket, which actually deals damage if I collide with him. Which is not the behavior that we want, but we can improve on that. And this little guy here, just to check, is it correctly spawned? So is it the same as in tiled? Yes, so there are these two black lines here, so the pixel borders, and we also have those two lines of pixel borders in our game. Looks good. So that's the first thing that we want to do. Then we need to adjust something. So we need to change the state management or state creation now a little bit. Because currently we have configure state, and there we just read this property if it has a state, and then we set it. But we want something different. So we want something like initial state. Most likely we want to call it like that. That would be a string. And the default value would be an empty string. And then we have something like if initial state is not blank, then we add it. But here we need, what did we do? We created here data objects. But I think we actually wanted to extract that this animation is then always played, but I think we can also keep it like this. But anyway, we need like the names of these game object states. There is now one downside to it. I am pretty sure we cannot convert a string to a data object by a name, right? I would guess that this is, how would that work? Initial state to game object. So something like that, or game object state, of course, that does not work because we would, so there we, I think there would be a solution if we go the reflection route. So from the class loader that we have on the JVM, we can most likely get the class by name, and that maybe returns this singleton instance here. Another approach would be that we have a huge or a big when statement. So when string da 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 return that object, when string da 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 return that object. And I don't want to write that manually, so that's why I think we convert that now to an enum, which makes it easier because then we can use the value of stuff again. But still, would that work? Yeah, we need to combine that everything under one single enum. Because I'm thinking now if I would have two enumerations, one for our game objects, one for the rocket, still I would need to know here what kind of enum I need to call with the value of method. So to get from the string the correct enum value. And then we would have the same problem here with the game object. So we need actually just one enumeration class which contains everything. It's not that great, right? It's really not that great. But I currently cannot come up with a better solution for that, to be honest. So I'm thinking of something like this. So game object state. How did we call it? Animation type. I think it was, yeah. So like this. That one extends the game object state, maybe. Is that possible? Okay, that should not be a sealed interface, just a normal interface. Ah, and that's the same name. Then I think we can, well, I'm not sure what the correct syntax is for that, but let's play a little bit around with that. So we also want to extend here the AI state, and we actually want to have the same, the same overrides that we had before. Yes. Is that possible? Expecting after last enum entry. And then we would have something like idle. And what else did we had? Jump, ball, and run. So jump, ball, and run. Okay, and then I would need to override here methods. How can I do that? Is it like this? Or is it objects? Something like this? Where I then override the... Looks like this is working. Looks like this is the correct syntax. So let's try it out. So this one would be everything that we need in our idle state. Then another thing for our jump state. Then another thing for our fall state. It's this one here. And finally, the run state. That would be that part here. So I'm not sure if we make everything correctly, but I just go step by step and try to fix it. So here we would go to jump. Here we would go to fall, and here we would go to run. Why does that work? That one takes a game object state. Okay. So that seems to work. Then here we have fall, idle, and run. And finally here we had jump, idle, and run. Okay, here below also jump, fall, and idle. Good. So let's make here some new lines between the different states to make it a little bit easier to see where a new state is starting and where it ends. Does that now still work? Let's quickly go back here and let me revert to the initial implementation. And here we would have the game object state idle. We would set it like this. Let's see. So if it did not break anything. Yeah, looks like it's working like before. So converting it to enumerations was not so complicated. Good stuff. Now we want to change this implementation. So let's go back to Okay, I need to write it down again. So here we have once more, we had here the string. We want to have here an initial state where the default state is maybe blank. So if something does not have a state, it simply does not get the component. So is not blank, then we set something, and now we would do something like game object value of, and then we pass the initial state. So this is the new implementation that we want to follow. Then we need to switch something in tiled, of course, which would be here our custom types and our entity definition instead of has state. Let's remove has state. Are you sure you want to remove from the class? Yes, I'm pretty sure. And we want to add something which is called initial state. And for simplicity, just a string for now. And by default, it's idle. Let's save that. Then in our object style set, we have here the initial state, which is good enough. But for the rock head, we want, let's call that, so here we have idle, jump, fall, run. And let's make a new one, which is rock head, idle. Which has no implementation yet, but we will add that in a moment. So here the initial state would be rock head, idle. So that should theoretically work already. Let's see. No. Because I don't see any animation for the player, so something is not working. Let's see what is the problem. Let's go down there. So we have here initial state empty. Why is it empty? I know. Because I think this is how tiled saves it. So here it's grayed out, which means we did not specify a default, or we did not specify a value. And I guess it's then also not part of the map file which gets saved. I'm not sure if I just write something, does it now? Yeah, now it's black. So maybe now it's doing something. Yeah, but then this is not correctly set up because our game logic is actually that the initial state is empty. So we should also represent that here in the editor. That was correct, that there is a default value. Now it should work again. Yes, because now we get an idle and game object value off. That should also return the idle state. Yes. No. There are no regions for the animation saw run. Huh? Where is that now coming from? Saw run. Yes, the saw just has an idle animation. So obviously we broke something now with the change to the enum states. What could that be? We can... It's coming from the AI entity. And seems like we are calling... Yeah, we enter the run state. Why are we doing that? Because the body is moving, which means we go to a run state. Why did that work before? Ah, wait, before the saw did not get a state. I think that was the thing. The saw does not have an initial state, right? I think it's easy as that. Before we had this checkbox and I think it was simply not set on the saw. Yeah, that should be it, right? Yeah, that's it. So that was the problem. We did not have a state for the saw because it does not have a state. It's just following the track and is always playing the same animation. So that's why we did not need that here. Okay, so that is also fixed. And now the difference would be that we should have two entities in this rockhead animation. To also verify that, let's go one step back to this game object state and to the rockhead idle animation or idle state. And let's override the enter method and let's just make here a breakpoint to see if we enter that one here 2 times. That would be my expectation. My expectation is wrong. Huh? Now I'm confused. Why don't we set that twice? So here we set the idle and then rockhead idle. I would have an idea for that. Let's see. So when we add a state component, what is actually happening? So we set the AI entity and we also set the game object state. And then we create a state machine where we pass this initial state. And maybe if we pass here an initial state, I could imagine that this does not fire the enter event of that state, which is actually not what we want. So we execute update, but we don't execute the enter one. For that, we would need an initial state of null and then call the, how's it called, set state or change state, and call change state. So this is actually a bug currently. Interesting. So initial state, can I leave that also empty? And can I call here apply? Does not seem like it. Required state machine. Wait. Then we have a state machine of game object state. Is that one working? Required state machine, AI entity game object state, bound state AI entity. Is that... wait, that's a little bit weird. So in my opinion, that should be then AI entity and game object state. And here we call the change state. That's a little bit too long. Something like that. Can I extract that? Let's call that default state machine, just a helper method, which we hopefully can still call. Okay. I'm almost there. Okay, so now the constructor looks clean. It's not so big. And we have here this utility method here that returns this default state machine. Now with the correct behavior, because now if we fixed everything correctly, this rockhead initial state, we should enter it twice. Yes, 1, 2, perfect. Okay, so that one is now fixed. We had a small bug there before, because when you set the initial state directly on the state machine, then it does not call this enter method, which maybe it does make sense to me. It's actually not consistent because I'm entering something because it's still the initial state. I would expect that the enter method is still called. But anyway, the implementation is not like that, and fixing it was not that big of a deal. Okay, one more thing. That one is now a little bit of a question mark for me on how to solve it, because this little guy here should actually have two sensors. I would say, for simplicity, our rockhead goes in 4 directions, so left, right, up, or down. So he needs like a sensor where he detects if the player is in range. And if he is in range, then he's going to stomp him. And I'm not sure if we can make that here in the collision editor, because we would actually need, let's see if that's working. We would need a shape that is way bigger than the graphic itself. So it looks like I can draw it like that, but not sure if it's then actually working and storing it correctly. So let's say, what do we have? Our tile size is 16 by 16, right? So I would say the detection range, or the aggro range, would be 4 tiles, which would be 16 times 4, which is 64. Is that correct? 40, 6 times 4, 24. Yeah, 64. So here minus 64 and plus side. Whoops. What did I do now? Minus 64. Okay. And the height would be, if it's now 64, it actually goes to his head, right? Then we need to add here another 42, which is then 106. And now here we also want to add 64, which would be 70, right? That does not look correct. That's not correct. 106 plus 64 is... But that is 170. Oh, 170. Is that maybe an optical illusion? But to me, the area here below looks smaller than the area here above. But maybe it's an optical illusion. So let's call that aggro range. So that one here has again a fixture definition. It is a sensor. It can be a chain, and the user data would be aggro or aggro vertical or vertical aggro. That's a better naming for it. So that would be the vertical aggro sensor, and then we would need the same for the horizontal one, which let's see, that would also be minus 64. The width is then 64 plus 42 is 106. It's actually the same, right? So what was the height here? 170. So it should be the same for this guy here. So width is 170. The height is 42. So it should be exactly the size. And it should look like this. Okay, then this one is also a fixture definition. It's again a chain, a sensor, and that would be the horizontal aggro. I am wondering if that is working. Would be very cool if that one is working. But let's see. So first of all, we need to go to our game properties and debug the physics, because we need to see if those sensors are correctly loaded. And it looks good. So if we are in here, he would detect us and then start moving towards us, which is good enough. Also, I like that because the graphic actually has a little bit of a border. It's not exactly 42 by 42, but that would be nice, because if we are like this, he should already change his animation and indicate, hey, I'm going to stomp you. But we are maybe, I don't know, let's say half of a world unit inside his range, then he really starts to attack, so something like that. So to implement that, we need to react, or the rocket needs to react to these collision events. That is what we need. And to do that, we have our physics system with the how is it called? Begin contact methods. Exactly. So there we had the damage collision stuff. Now we need some additional things, but only for the begin contact, I would say. So here we have something if is aggro sensor collision entity A, entity B. do we actually need the entities here? No. Yes, I think we still need it. And then fixture A and fixture B. Let's see. So something like that. And here we want to do something. So most likely our rocket needs like a list of entities which are in his aggro range. I think that would be the easiest way to implement it. To just keep a list of entities which are in your aggro range, and then at some point do something with those entities. So I would go the route to create a new component for that, which we will call aggro component. And this aggro component, as mentioned, it will keep entities or aggro entities, maybe we could call it like that. And that would be a list of entity. Yeah, I think that's it. So a list of entities, which you don't actually need to provide because initially it's just an empty list. That makes sense. What else? Then somehow this component needs to be added, and to be consistent with our configuration stuff, we will have something like configure aggro, where we pass the entity and the tile. And this method here is not part of the tiled service at the moment. It's in a separate file, which is here. And then let's add it at the bottom. That's also nice for the Git history. And what do we actually pass in here? It's a tiled map, tile map object. And let me copy this one here. So tiled map. No, it's just not the tiled map tile, right? Not the object. Where is it? Tiled map tile. Yes. Okay, that cannot be empty. And here we want something like we have the tile and we get the Boolean has aggro. Little bit thinking if that is really what we want. And there we would add the aggro component to this entity. And this one is actually an extension function of the entity create context. Okay, so that would allow us now in tiled to have a new property where we can say if it has an aggro component or not. Yeah, let's try that out. I read the comment in a moment. Let me just finish this one here. So we have here the entity definition with all the different properties. There we add now a new Boolean type, which per default is false. But our rocket will now have the aggro set to true. And that way, let's make here a breakpoint. We should enter this piece of logic here 2 times. Here it's not make configure aggro public. It was private. Yes, it was private for whatever reason. Now it's available here. And now we should enter it 2 times, right? Yeah, okay, and let's comment out this little logic here. Okay, that's the state stuff. Okay, 1, 2, perfect. So 2 times we enter now this little logic here. So our rockets now have an aggro component. So the last piece to make the enemy do what we want him to do would be to add here now a logic. So if something gets inside an aggro sensor, then it gets added to the list of entities in this aggro components. And then in our rocket idle state, there we simply check, is there an entity in this aggro range? And is it a player, for example? Maybe he just reacts to players. And if yes, then he changes the state and does something. That would be the idea. Okay, so aggro is a component class. It's a flex thing. Wait, what? I overread something. Is aggro an annotation class? How can you return aggro without .class or anything? No, aggro is a component class. It's a flex component thing. Yes, that's right. So I have this live template here, which automatically creates this component thingies. But just to give you an example here, so it's basically a component. So component is a part of an entity component system. And it also has this component type, which, to put it simple, it's just a unique ID for every component. So that in the background, you can imagine that components are stored for an entity inside an array. So you have an array of, 10 components. And every component needs a unique index in that array. And that is this component type class, which automatically creates this unique ID. And yeah, that's the flexibility with entity component systems, that you don't have a class or a hierarchy of classes which contains different type of data and behavior. In an entity component system, you just have, I would say, different pieces of data, and usually these so-called systems, which are then doing something with that data. And the advantage of this approach is that you are very loosely coupled when you are developing something. So we currently would create a lot of different combinations of entities, as you already see it here. So this is where we create the main entities, let's say. They have this tiled component that we just have some relation to the tiled map object. But in the end, we can add a physics component or not to give it some physics behavior. We can add the graphic component to give it a render representation, a graphical representation. We can tag it with certain stuff. We can add an animation, and we can create different types of entities. So for example, an entity without an animation, then we just don't add the animation component. If an entity cannot jump, we just don't add the jump component. If an entity does not have life and cannot take damage, then we simply don't add the life component. So there you have then this flexibility, I would say, if you go this entity component system approach. But still, how can you write function x equals aggro? Is it a Kotlin object? What's the return type of the type function? What do you mean by that? Do you mean this one here? That's a Kotlin thing, actually. Yes, and it's basically an operator. So in Kotlin, you can have special kind of functions which are called then operator functions. And one of these operator functions is, for example, this plus assign, which is then basically this operator here, this plus equal. If you would like to call it like a function, it would be plus assign, something like this. So this is then how you would write it in Java, where you don't have this operator function stuff, where you just call the method. And in Java, it would look something like this. But in Kotlin, I guess this is just some personal preference, and I wanted to stick with the Kotlin standard library functionality. And that's why in Flex, for example, you have this plus equal, so this plus assign operator to add a component to an entity. No, in the component where you have type equals aggro. Ah, this one here. This is also, yes, this is also a Kotlin thing. It's just a shorthand. So if you have a function like this, that one returns a component type of aggro. So if you have very simple functions, usually one-liners, so a function and then just one line which returns something, then in Kotlin you can simplify that and make that I don't know how that is actually called. Is it called short something? Convert to expression body. Ah, okay, so they call that expression body. So instead of having then the curly braces with the statements inside, you can just have an equal sign, which is the short form for what we had before. Instead of writing curly braces, return something, you can just write equal something. And because Kotlin has a, how is that called? Dynamic type detection. If we basically return, delete the return type like this one, then Kotlin automatically knows, okay, since the return type of this function is the aggro component type, we don't need to specify the return type. So this one-liner here, the short one, is the short format for that one here. It's also just some Kotlin stuff to make certain things a little bit shorter. I would say if you are not very used with Kotlin, like I was initially, of course, it's sometimes a little bit tricky or hard to understand those things, or not so easy to read. That's why I think some of my viewers always, they say that they prefer Java over that, because in Java you are forced to write all these boilerplate thingies, let's say, which sometimes makes sense in my opinion. But especially in that case, every component always has this type function. So this is a function that is mandatory by the component. And in 99% of the cases, it simply returns the type here below. So this companion object. And to keep it short, to not always have these 3 lines, I think that one is just way easier. Also, you can basically ignore it. It's just some flex internal thing that is necessary for the entity component system, and to not overflow the code with something special. It's just this short line here that returns basically this instance here below. And this is, by the way, also some Kotlin related thingy. The companion object is like I don't know how you would call that. It's a static instance, or the place where you would place the static variables of your class. So in Java, you would have something like, do we still have the playground from last time? Then it's maybe easier to explain. Yes, we should still have those two. Let me split that to the right. And let's make that small, and let's zoom in a little bit. So just to give you the Java counterpart. So let's imagine we have a data, just a class. It's not really important. Foo, which has a variable string, which is a string, and that's it. In Java, it's the same. We have a class foo, but here we would need to specify it here below. So we have a private string, which has this initial value, and we would have here a getter and a setter for the string stuff. So what we have here, I can also remove these curly braces in Kotlin. So this class here is that representation here in Java. And now let's start in Java. That's maybe more intuitive for you. In Java, you can have then some static variables, like, I don't know. In our case, we would have something like public static integer ID, and that is then some special ID. So you usually in Java, you have this static field somewhere, normally at the top of the class. And in Kotlin, the same thing would be that you have a companion object. So in here, we would have an const ID, which is 1, 2, 3, 4. Const val ID, something like that. And I made the semicolon for whatever reason. So this static int line here, in Kotlin, it should be, or it must be part of this so-called companion object. Then here my knowledge is a little bit not so deep, so please correct me if I'm wrong, but from my understanding, the companion object is then actually a single instance, like a static instance of this foo class, which is somewhere in the memory of our JVM when we run our application. So inside a main function, we can write something like foo.companion.id to access this ID field. And you see here, so this companion is like an instance, a static instance of this foo class, so a singleton. It's just one specific instance, and you don't need to write companion. So you can basically remove it and just write foo.id. In Java, again, we need here the public static void main. We have the sys out, and there we would have then foo.id. In Java, it's like this. And then there is some special thing in Kotlin, because since the companion object is a real instance of an object, it can actually inherit from something. So in our case, it implemented this component type, which I don't have access here in the Scratch file. So let's make another one, I don't know, comparable foo, which basically means this component object. So this instance that we can access like this can also implement certain interfaces or even abstract classes. And here I would need now to implement the method. But now our companion object would be a comparable, which does not make sense at all, but you could do something like this. And in Flex, we have the component type, where we actually create an instance of it, or call the constructor of this component type, which is I don't know, is it an abstract class? I cannot remember. But basically, the companion object of the component does then have this unique ID automatically generated. And then it's just some syntax sugar in Kotlin that you can write then just foo, which then returns this companion object instance. So that's why we can then write something like entity and then component blah, something like that. And in the end, what we write here, so if we just write the component name, Kotlin will actually return the companion object instance. This is why that is working. So it's some Kotlin syntax sugar, let's say. In Java, if you have a class named animal, you can't write return animal. You would have to say return new animal or return animal class. Yeah, so as mentioned here, it's a little bit special because it's actually this companion object, which is just one single instance of the class. So it's a little bit related to the static stuff in Java, but it's really an object instance from what I know, at least. This is how I imagine it, how it works. I don't know how it's really implemented in the background. But since it has this name object, and object in Kotlin means usually a singleton, so one instance. In Java, if you have a class named animal, you can't write return animal. You would have to say return new animal or return animal class. How do you do it here in Kotlin? Not 100% sure if I understand you, but you mean like here, for example, if we have our foo class, you would need to write it like this, right? New foo. And in Kotlin, it's basically the same, but you can skip certain things. There is no new keyword in Kotlin. You just write foo like this. So the new keyword is not necessary, which in my opinion actually makes sense, because if you have an object like our class here, and you call the function like this, it's in my opinion very obvious that you always call the constructor. So this new is a little bit redundant. Of course, when you look at it immediately, you see in Java, okay, here a new instance is created. But let's be honest, if it would be written like that, you would also know, okay, there is a foo instance created, or something foo is called. And when you look at it, okay, that's the class. So obviously I'm calling the constructor. So that's the only difference here, I would say. You just remove the new keyword. I hope that explains it or answers all the different questions. Maybe one more thing to explain this short syntax again in Kotlin, where you can shorten certain things. So let's say we would have another function. I don't know, let's call it new foo, which returns an instance of foo. And there we would have something like this. So now here, if we call now this new foo function, and let's initialize here the string with blah, and then we can have here new foo dot string. And I don't know how to run that in this Scratch file. Do I actually just remove the main method to see the outcome here? How does these Scratch files work? I don't know. Anyway, let's return it. Just believe me, so if we would print it like this, here we would see blah, because new foo is creating a new instance of our foo class, and there we have a string which gets initialized with the value blah. In Java, you would have almost the same. So we would need here a static new foo like this, and there you return a new instance of it. And then down here below, we could write something like new foo and then get string. That would be the Java counterpart for it. So this method here, the static method, is the same as we have it here. Let me maybe scroll it that they are almost next to each other. And yeah, so in Kotlin, we can now, as I explained it before, we can remove certain parts because they are not really mandatory. And saying that, if you have more complex logic here, I would not, or I personally don't prefer the shorthand syntax. I prefer then the declarative way here to make it more obvious what is actually happening. But if you really have very simple one-liners like here, to me, I prefer the shorthand syntax. So first of all, in Kotlin, we can make this one here, so the curly braces with the return type, we can make that to an expression body and just say that this function is equal to a new instance of our foo class. So it's still the same as we had before. So instead of having the curly braces with return something, we just have the equal assignment, so this expression body, but it's still the same, so nothing has changed. And one final thing that we can simplify is then, because on the right hand of this equal sign, you already see what this method is returning. So we don't need to specify the type here. It's obvious what it's doing, so we can skip that as well. And now the behavior is actually the same, so we did not change anything, but it's just way shorter to write it like this. And this shorthand syntax, I prefer it for certain things. Like imagine you have an add function where you have an x and a y, and then you would just return x plus y. So something like that, in my opinion, is there it makes sense, or it's a nice addition to the language that you can write something like this, instead of writing then here that this returns an integer and then the return value would be return x plus y. You can of course still write it like this, but in my opinion, for very short function, as mentioned, I simply find it easier to read and it adds less noise to your code if you have the shorthand syntax here. That's it. So this is just some Kotlin stuff that's happening there. And now coming back, so let me know if you still have questions. There's always a little bit of a delay if people are writing something, but I hope that answered it a little bit. So now coming back to our rocket enemy. So we need our physics system. And now we need something to detect if the player is within an aggro sensor. So we prepared there a little method that we now need to implement, which takes the entity A, the fixture. The fixtures cannot be null. That's impossible. And what do we want to check here? So let me see. Where do we have the damage collision? That's here below. So let's also move this method down below somewhere. And now, so what do we want to do? We want to see. So entity A has an aggro component that is important. And what would we then do? So entity B is whatever. We don't really care. I think that should be part then of the rocket state logic, that it then checks what kind of entity that is and then either attacks it or not. But the important part is that the fixture of entity A, the user data, is equal to aggro sensor. And to simplify that, one moment. How did we call it like that? So hitbox equals user data. So here we have that one we can also then simplify. And I would say the fixture B from, so the enemy that gets in contact with the aggro sensor should be the hitbox. I think that makes sense, that we just react to hitboxes. Here, that's currently not working because we called that horizontal aggro and vertical aggro. And I'm now thinking of just call that aggro sensor or something. How did we just call it in the code? Aggro sensor, yes. To keep it simple, because it does not make sense, or there's no difference in our logic if it's the vertical or horizontal one. The important part is if an entity comes within that sensor, then we want to do something. So we can stick actually to the same name. And to be consistent with what we had before, we make here another one, which we call is aggro. And here the user data is aggro, and maybe one more thing is sensor is equal to true. Yep, I think something like that. Maybe sensor check should be first, then we don't need to do the string comparison at all. And that's it. So an aggro sensor must be a sensor, obviously. And the user data would be aggro. Okay, so that means we can here call now fixture A is aggro. Is aggro sensor collision? What is aggro? Just aggro. But let's call that is aggro sensor. And I'm not sure, do you write aggro with double G? I guess so, because it's maybe related to the word aggressive, and that one you also write with double G. Okay, then entity B is not relevant for this function actually, so we can remove it. And call it then like this. Okay. And then we want to have here a handle aggro begin contact. And there we pass in entity A and entity B for now. Then let's create this function. And in here, where do we have all these other begin thingies? We have that here. So here we had a debug message, which is also maybe important, and then some logic. Okay, so begin aggro collision between let's also make that more meaningful names. So aggro entity, and that one here would be the trigger entity, which triggered the aggro sensor, something like that. Okay, and finally, we then just need from our aggro entity, we need the aggro components, and there to the list of entities, we would add the trigger entity. Yeah. Which means that this must be a mutable list. Yeah, I think that should still work. Okay. And I think that's everything that we need. The last thing would be when there is end contact. So if we leave the aggro sensor, then we need to remove the entity from the list. Yeah, that also makes sense, right? Then here we need to duplicate this logic here again. Still not sure if there is a better way to do that in Box2D, where we call it with the reversed arguments like that. AAB, BBA, AB, BA. Okay, that looks good. Then I also want to replace that with when statement. I think that's a little bit easier to read. Okay. And finally, in our end contact, we have something similar. So also let's make that when. Like this. And here we have something else. So if it's aggro sensor collision, then it's actually handle aggro end contact. So what does that mean? How can we easily debug now if this stuff is working or not? I would say we need to go to our game object state. And there we have the rockhead idle, and there we override the update method. Which does currently nothing, but we want to have here something like entity. And there we just want to access maybe the aggro component. And then, yeah, for now, just print line the amount of entities which are getting in contact here. I think that should be it. So there is obviously some syntax highlighting issues, I would say. Yeah. Maybe that spams too much, to be honest. Because we... Okay, wait. One thing how we can easily make that now. Let's, for now, remove one of these rockheads. That we just have one. Because then the sprint line spamming here just represents the number of that one little rockhead, which is currently an empty list. So now we are in contact, but it did not work. Because now I would expect that here we see the player entity. Why is it not working? Let's see. So physics system, begin contact. Here we need a breakpoint in a moment. So now. Okay, now let's do breakpoint. And now end contact. Why end contact? No, I don't want an end contact. I wanted the begin contact. Maybe I set the wrong breakpoint. Okay, so we have entity A and entity B without any information, but I think, can we write something like this? So entity A has aggro. Okay, so one of these entities is now the rocket. Entity B has no aggro, I would say. Yes. Then let's see what happened now. So in here, we should have entity A has the aggro component. The fixture A is not an aggro sensor. Why? Haha. Why is that? I could imagine, let's see, let's go into this method. Ah, so the user data is aggro sensor, not aggro. Okay, so that was the mistake. Now let's stop it. Now I would expect, yes, so now we are part of the entity list, and when we go away, it's an empty list again. Okay, I think that looks good for now. That looks very good. So coming back to our state, now in here we need to do something. So what do we need to do? We want, what do we want? We want to check if aggro entities is not empty and if one entity should be attacked. For example, I think we keep it simple and we just attack player entities for now. If that's the case, then go to Rocket aggro state, or how did we call this animation where he's then changed or where he's opening his eyes? How did we call it? We called it aggro, yes. So that would be go to Rocket aggro state. And finally, if entity is too close, move Rocket to entity. Okay, and otherwise, if entity leaves, otherwise if aggro entities is empty, it's not really that one. If aggro entity is no longer in range, then go back to idle state. I think here we will also need in the idle state, somehow he would need to go to his initial location. So maybe inside the aggro component, we also need to store the source location or the starting location of the entity, that when it moves somewhere, that it goes back then to its initial state. I think we need something like that. Yeah, so let's implement that. Let me also see if we can somehow fix this syntax highlighting issue. No, for whatever reason, we have here very weird syntax highlighting. I don't know why. So what do we want here? I think I'd take a short break. Need to go to the restroom, my friends. And when I'm back, then we are going to implement that little thing here. And that people are not bored staring at code. We will have our game here open. That you see something. And also the code that we are going to implement. And that's it. See you in a moment. Is the stream live? Yes, it is, but I had to take a little break. Hello, Omega Destroyer, if you're still here. Good, so what we need to do now is implement that stuff over here, which should hopefully not be super difficult. So what do we need? We need to check, maybe we want to have something like this. So if entity, and then a method that we call has aggro target. Let's call it like this. And if it does have that, then we going to change the state to rockhead aggro state. And that one we did not implement yet. So we will have another state here. And in here, we actually want to override the enter method because we want to set the animation to animation type aggro. We don't have that yet. Let's quickly add that, which would be aggro. And here we might need to change the animation speed and also just play it once, so that should not be looped. I mean, for now, let's keep it in the looped version, then we see if it's working or not. But we definitely will overrule that or change that it just plays once. Also over here, when we get in here, we change back to the idle animation type when we are in the idle state again. And yeah, and then below here, let's prepare the update methods and let's move down the to-do stuff over there. So that part would be done. That part would also be done. We have then this one here. So if it's too close, then we start moving. And otherwise we do something else. Okay. So what we are missing is this little method here. So how do we know if there is an aggro target? It's basically accessing our aggro components. We need to be in the context of our entity world. Okay. And now in here we get the, we also return a Boolean. Yes, so we have the aggro entities. We could actually destructure that, right? Aggro entities like this. And if aggro entities is empty, then we know there is for sure nothing in range. And otherwise we check, we could write it the Kotlin style. Not sure if that is ideal from memory point of view, but I think it's a very nice way to write it down. So it has entity tag.player and first or null, I would say. We can write it differently. So first or null. So we get the first entity, which is a player. And we know if that one is not equal to null. Yeah. Then I think to make it even better, also for the remaining logic that we are going to implement, we just call that aggro target, which returns actually an entity or null. And here it returns obviously null. And here we return the result of this call over here. Okay. Always returns non-null type. Why? Returns the first element matching the given predicate or null if element was not found. in my opinion, this can be nullable. Hello, Maxwell. So back there, we have then something different. So in the update call, we have then entity aggro target. And let's say if there is an aggro target, then we want to switch over here and also to do set aggro target on aggro component. So there we need to update something a little bit, but let me quickly check that. So now we should at least reach this aggro state once. So if there is an aggro target, which means there is an entity in range, which is a player, we will switch to the aggro state and we should see a different animation for the rocket. Let's see if that is working. So currently he's doing nothing. Okay, now he is in the aggro state. So that one seems to work. And obviously, since we never go back from that state, he's playing this animation endlessly. Let's try it one more time, a little bit slower. So currently, he's not doing anything. And now we are in range with our hitbox. So he's now aggroed. And maybe when we are very close to him, I don't know, within 2 world units or something, then he starts to move. So something like that. What type of game are you making? It's a platformer game, but it will not be a completely finished game. It will just be implementing all the basics and the engine that we need for that little game, but then adding the content, so different maps, boss fight, whatever. So to make it a complete game, we will not finalize that. For me, it's always just very interesting to learn or implement the different features of a game. But then at the end, adding all the content and making it a complete game, I rarely do that nowadays. I did that for a couple of games already, which I also deployed on Play Store, Google Play Store. But for new games currently, usually I don't do that. I'm just interested in find the solution for certain problems and yeah, have that available. But in the end, it's a 2D platformer where currently we have one enemy, which is the saw, which can also follow some tracks. That one we have already implemented. And today we're going to implement this rocket enemy here, which has these sensors, as you can see them here. And now we are adding the logic that he's then really attacking the player at some point. So what are we currently missing? So we are currently missing that this animation should not be looped. It should be just played once. And anything else? Yeah, also he never leaves this state. So let's fix those 2 points here. So for that, we need to do something in here. So let's say aggro state, and maybe here we can also pass a play mode that is called normal. Then I think it's not looping, right? Yeah, let's say normal. For that, we need to add here a play mode argument, which by default is the loop version. And then we have this one here. And there we have entity animation. Yeah, all of that looks good. What is actually happening in here? So for our entity, we get an animation and we access the animation component, do something and also set the sprite. So what we would also like is that here we pass a play mode. Yeah, then we need to rewrite this little code here. So here we have the animation component. And for this component, we are setting that. And also there is a play mode, which gets set to the play mode that we have here. And now let's see, when we update our entity, we set here the play mode and get keyframe. What is that? I think we are missing here something. Looping equals to true. We don't set looping. We set here the play mode of the animation. Yeah, okay, so that should already work, I think. Let's see. Here we also are now missing the play mode, which per default would be the looped version. Whoops. And we pass that here as the third argument. And finally, in our AI entity here, we pass the play mode as a third argument. And that should fix already the animation issue. Let's see. So now when we get to him, I think it was correctly played, but it was actually played very, very fast. So he immediately opens the eyes. What kind of animation do we actually expect? So it should be aggro 0. That's the same as idle. Yeah, then aggro 1 looks almost the same, I would say. And then aggro 2 is already with the opened eyes. Yeah, okay. Then it is like this. I thought there are a little bit more animations, but this one seems to work. That is good. Then now we need to update our aggro component. So we need certain information. First of all, we had this list, which is fine. And that's also the first thing that we want to deconstruct when we deconstruct the component. Then we actually need aggro target. Let's just call it target. That would be an entity, and there is a non-entity in Flex that we can use to don't require the null. Safety, or do we actually want here the null check? No, then let's initialize it here with null so that we can use the question mark null stuff to see if that target here is available. Let me think. We go with the not null approach. I prefer that. Let's see if that works out. And what else? We also need the source location, which is a vector 2. And that's it. So when we create the aggro component, which we do in here, we need to set now some additional things. So the aggro entities is okay. Target is also okay, but we need to set a source location. And the source location is what exactly? I think it's from... Let me quickly check. So when we are creating an entity, we have a location, right? A position that we pass in here. What position? From the body, the position, which is the bottom left corner. Okay, so coming back here, that is then basically from our physics component, the body position. And we need to be careful here. That actually needs to be a new vector 2 instance, right? Copy, maybe? Like this? Yep. So we need to be careful, because if we would pass here the position vector of the body itself and we modify it, we would actually modify the physics body position, and we don't want that. So this is really the source position. It's just set once. Yes, it's a value. And now if we would move the rocket, we know where we need to go back. So that would be also good enough. And finally, in our state, so in here, we would say, what would we say? We would get the entity acro component and set the target to this target that we have here. Okay. And finally, we will then go to this acro state. And here we need something different. So if acro target in range, maybe. Acro targets. Yeah, maybe we should get back here a value. Also not sure. Let's see. We would most likely need the width of the sensor. So what is the actual range of the acro? Maybe. Because somehow we would need to know if the entity left, but we already know that with the entities. Okay, then we can do it differently. Let's see. If acro targets in range, then we do something. So we would here change the state again to rocket. Let's call that attack. That's the last state that we need, where we do something. And here when we enter this state, we play the animation type run, I think we have for the last one, right? Yeah, we had the run animation, which can be looped. And we also have an update method that we don't have yet implemented. So that would be a to-do. So if acro target in range, and let's say here, that would be 2 world units, maybe. Let's see. So we have here a range of 1, 2, 3, 4, 4.5 world units. So 1 world unit is 1 tile. So I would say when it's in range of 1, 2, maybe 3 world units. 1, 2, 3. 3.5, maybe here. When the player is too close, so 3.5 world units, then we go somewhere. So if target is in range 3.5, then we change to the state attack. And otherwise, if acro target, let's see. Is that null again? Let me see. I think the easier way, or one thing that we should do, so begin contact, that's totally fine. The end contact of our thingy here. So there we should do something like, let me see. So if we remove it from the list, that is okay, but also we need here the component. Also, if acro component target is equal to the trigger entity, then we want to reset it to entity.none. Which would mean, so the rocket was locked to this specific entity here, but it left the sensor or the range, which basically then, so that's the equal assignment here. So the target would then be reset to none. And now in our state logic, we would need, I think we rewrite this here a little bit. So we have here our entity, then the aggro component. And from that one, we want to get the entities we don't care. We want to get the, what is the second argument? It's the target and the source location. So we want to get the target entity and that's it. And now we would need something like, let's call that entity dot in range. So more generic function, which I like more. So if is an entity in range of target entity and 3.5 world units. Yes. Also, then we change to the attack state. Yeah. Otherwise, if the target entity is equal to entity none, and maybe that should be even checked first, then we go back to the idle state, right? So rocket idle. Yeah. Okay, so this to-do can be moved down to the last state that we need to implement. And here we are now I think we are almost done. So first of all, this check here should be the first one. And then we check this one here. Okay, and now we need this in range method. Target range, or just call that tolerance. And how do we compare that? I think we just get just the physics components. I think that's good enough for our game here. So we will have the entity physics, and there we get the no, that's not what I want. Well, why is it like that? Why don't I get the destructured version? The first one should be the body. Yes, so here we get the body. Okay, and return false. And then also from the target we get the target body. And then it's simply, how do you calculate the distance between 2 points? Is it something y2 minus y1 multiplied with x2 minus x1? And then the square root of it? How's that called? Let me check. Let's call AI. What is the formula to calculate the distance between 2 points in 2-dimensional space? That's the thing that we need. The formula to calculate the distance between 2 points, the Euclidean distance, and it's the square root of something. And we don't want the square root because that's a quite slow operation on your computer. So we can simply do it without the square root, and the distance that we are checking is simply then doubled or multiplied with itself. That should be it. Okay, so that sounds quite simple. So we have something like let's call it val difference x, that's equal to target body position x minus body position x. Then we have the difference on the y coordinates between the target and the original entity. And then we simply have diff x plus diff y multiplied by diff y, and that one should smaller equal to tolerance times tolerance. That should be the thing that we need. Omega destroyer x minus x2. Yeah, exactly. That's the Euclidean distance formula that we needed. Sorry, I don't know how I can reduce the delay in the chat messages. I think there is like half a minute of a delay. So sometimes you answer my questions, but I just see them then like a minute later. And unfortunately, I don't know how to optimize that. I'm sorry. But yeah, that should be it. So this Euclidean distance. Let's also make a breakpoint here. We should enter that at least once, hopefully. So, it makes me crazy that the syntax highlighting is not working in this file. So what is he complaining about? Redundant empty class body. Local variable underscore entity should start with what just happened? Ha! We fixed the highlighting issue with something. What the hell just happened? What does it say here? Unused import directive, but that's also not true. So it seems like here it's a little bit confused since we refactored that to an enum class and have overwritten the different methods. Seems like the editor here is a little bit confused for whatever reason. Anyway, we were in our aggro state, and there we checked. So if the target entity is entity none, which means there is no target anymore, we will go back to the idle state. Otherwise, if the entity is in range of this world unit here, then we go to the attack state. Yeah, and finally, when we are here, we play the run animation, and if entity is too close, we go back. Yeah, maybe here we would have the same check here. Yes. There is also one additional scenario that we did not account for, which might not be possible in our game. But one thing would be that the entity that gets in range actually dies, so it gets removed from our world. Then, of course, that also should move the rocket back to the idle state. But I think that scenario currently cannot happen, so we skip that. In here, we want to have something very similar. So if the target entity is entity none, then we go back to the idle state. And otherwise, we know that the target is still there. Maybe still the check as well. Maybe it's exactly the same as here. So if it's in range, not sure. So in here, most likely we want to move or somehow move the rocket then towards the target entity. there would be one additional thing. So if it's not in range, so let me think, what do we have here? So either the entity is anyway out of range, so it's out of the sensor, then we go back to the idle state. Otherwise, we still have a target, and there are two scenarios. The first one would be it's in range, then we're going to attack it. And if it is not in range, then we go back to the aggro version, right? I would say so. I think, is that correct? Or do we always just go back then to the idle state? I think idle state would be correct, because in idle state, most likely we also go back to the source location. Not sure. We anyway need to try that out and then optimize it according to our needs. So let's try that out. We should see something happening. So closed eyes. Now the eyes are a little bit open because he's almost triggered. And aggro collision. Okay, now he's attacking us. But that's weird. We somehow triggered an end collision. Ah, could be because those are chains and not boxes. Wait, let me check something if we can quickly fix that. So my idea is, let me check. So this should be not a chain, and this should also not be a chain. So I think one problem that we had, also let's start in debug mode. One problem that we had is that those were chains, which means I'm getting in contact when the hitbox of the player is intersecting the chain. But actually when we are inside here, inside the sensor, we still want to have the contact event. And I think when we now converted it from a chain to a box, I hope that the contact still remains if we are inside the box. But let's see. So, okay, distance would be... What's the distance? So we definitely enter this breakpoint here where we check the distance. And distance is 37. And our tolerance is... We need to multiply it with itself. Is 12. Okay. I think maybe that's correct. Not 100% sure, but maybe that's correct. So we are still here. Yeah, looks good now. So now we are still in contact. And here he is now opening his eyes. And always remains in that state because we did not fix that. But when I leave it, then he is idle again. Okay, that looks okay. Let me check one more time. When does he open his eyes completely? Now. And that would be a distance of 1. Ah, wait. We are checking the distance from the bottom left corner. That's not correct. That's wrong. So we are checking the distance from here, which is now 1, 2, 3.5. Maybe something like that here. But we need to check it from the center, actually. Aha. I would say the distance between the two centers of the bodies. That makes more sense. Unfortunately, the body does not have a width or height because the physics body is just a combination of different fixtures and they can be anywhere. So we choose a different approach, which is we use the graphic. From the graphic or from the sprites, it's not called sprite, it's the graphic component. And from there we get the sprite. Let's call it sprites and target sprites. And here we actually we don't want the position like that, we need the good one. We need the center X, which is the sprite X plus the sprite width multiplied by half. The same on the for the Y coordinates. There it's the Y and the height. And the same thing for the target center X. And there it's the target sprite. And also here it's the target sprite. Okay, and we actually want to calculate then the distance between the target center X and center X. And the target center Y and the center Y. That should be now more accurate. Yeah, let's try that one more time. So now we are here. Okay, and let's see, when does he open the eyes? Here. That would be now one. Okay, since we are calculating from the center, that would be here. That's then 1, 2, 3.5. Okay, I would say that's maybe too close. Let's increase that to 4.5 world units. I think that will be a lot better. So now even that one is not high enough. Yeah, we go up to 5. Let's see if that is now better. Ah, wait, we changed it at the wrong location. Still, let's try it with the value 5. Okay. So when we are at that one, so here, he's opening his eyes. Yeah, and when we are not completely inside, but almost completely inside his aggro range, he's opening his eyes and then he will move to us. I think that is good enough. We should still extract this value here because we have it at 2 locations, and as we have just seen, easy to fix it, to forget that this needs to be adjusted in 2 locations. So have the rocket attack range equals 5. And let's replace it here and below with the rocket attack range. Okay, that looks good so far. So the only thing that we are missing now is well, 2 things. So in idle state, we need to go back to the source location, but that's not a problem yet because we never moved the rocket. In here, we now want to move the rocket. Left and right movement should not be a big issue, I think. We can access here the move component and then give him a direction. And for example, just to keep it simple, to see if that works, it would be move direction right. So now he should already move to our location when we are too close. Yes. And he's also pushing us, and he and he never stops moving. But that's already working, so that is cool stuff. I can also not move towards him, which is also great because his density is way too high, so he's always pushing the player. That's great. currently, our move system doesn't support that you go up and down, because we thought that this is always realized via jumping, but those rockheads, they are not jumping. So maybe we need another move direction up and down, which is the same then left and right. Yeah, let's think that through later on. For now, let's make one little fix. Let's make here another extension function and call that move. Should he stop somewhere or should he move almost forever? I would say he just moves one specific direction at that point. So we need something like entity angle to target entity that returns the angle in degrees. Maybe that's easier. Let's call that also angle degrees. And then if angle degrees is, what is it? It's within plus 90 and 270. So if it's smaller than 90 and greater equals 270, right? That would be the right half of it. Maybe let's make it a little bit more accurate. So 45, and is that 315? Yes, 315. Then we move him to the right. That one is move direction right. Otherwise, if the angle degrees is greater equal 90 plus 45, what is that? That is 135. And it is smaller than 180 plus 45. That would be 225. Then we move him to the left direction. I don't like this code here at the moment at all, but we can refactor it at the end anyway. So what we need here is this member function. Let's call it target. And that one returns a float. And how do we calculate the angle between 2 points? We already had that before, which was something with the arcus tangens 2 stuff. Let's copy paste this line over here. And what do we need? So we need the 2 positions. Yeah, and for that one, I would again use the same approach as here. I think that should be good enough. And then we simply return the arcus tangens 2 with target center y minus center y and target center x minus center x. And I want to multiply that with a constant, which is radiant to degrees. Then he's complaining here that this is duplicated code. Yeah, refactoring is happening at the end. Don't cry me a river. And in here we should now get the correct angle and hopefully move him to the right side and left side. And maybe that should be a separate state. I'm thinking now. Maybe the attack state that should immediately already move the head, and we don't need these checks here at all. He simply stops at some point when he is too far away from his source location, and then he just moves back to his source location. Maybe that's it. And the moving back to the source location could be part of the idle state. None of numbers is less than 45 and greater than 135. You're totally right. This check can never be correct. So it needs to be less than 45 or... But that one should still work. But that one was totally wrong. Yes, you're right. Thank you, Nevdatni. So anyway, here, again, aggro range. And at that point, we know that the target is in range and we want to attack. So I would say we make the logic that we have here is actually part of the enter state. So like this. Let's call that move rocket to target entity location, or move rocket towards target entity location. So something like this, yes. So here he would then move already, and in the update method, we just want to check. We again need the our component here, but this time we need the third information, which is the source location. And here I would just say if entity in range source location, and maybe let's call that not in range of source location. And how far does he move? Maybe, I don't know, 7 world units, something like this. So if he's 7 world units away from his source location, then we change back to the rocket idle states. Maybe that should be even as a separate state, which is maybe rocket return. So on his way back, he does not do anything anymore. He's just moving back to his original location. I think that is maybe a good approach. Let's see. Here we also get a warning. 2 comparisons should be converted to a range check. Okay. What else? But doesn't the range create a range object all the time? Not sure. If we don't have performance issues, then who cares? Then let's create another function. So here we have the location, and we can actually reuse that for this method here. So here we can then call, so this is a very simple one. Let's see, I think that's really a simple one. So we just need the sprite like here, then we need the center information like here. And finally, we just need to return the difference. And here we have then location X and location Y. Yeah. And this one, but that one is not in range, which means here we would have a greater something. let me think. Yes, so not in range means that the difference here is greater than the tolerance. And maybe the same thing again for in range, if we need that in the future. And there we have the less equal part. And here we just can call that here and return in range. And the location would be target center X, target center Y, and we pass the tolerance to it. So we don't need that stuff here. We don't need that stuff here. We don't need that one here. That should be it, right? You can check range object. You can check range object creates tools, Kotlin, bytecode, or something like that. Decompile. Ah, you mean before, yeah. One moment. So here it's complaining duplicate code. I don't care for the time being, but that should be good enough. So here, the float range 2 creates a closed floating point in range, which is a closed float range. And that one is an object from what I see. Which has some functionality in it and remember some values, which would mean that in here we always create this closed range thingy, which could be, of course, just, I don't know how smart it is. Maybe it just creates this range one time. If it wouldn't, then we could extract it as an object. But anyway, why is it still complaining? I don't know. But anyway, this should not be a big issue for us now. If it would, we will notice some performance issues, some lagging at some point, but that's it. So let's think it through once more. What did we do? We now have the aggro state. When we are in range, we go to the attack state. Here we changed now that when we enter that state, which is just once, we calculate the, let's make a breakpoint here. We calculate the angle between the two entities, so between the rocket and the target that was identified here at the top. And then we move him either to the right or left direction. But we also need here move top, bottom. That one we don't have yet. But this one should work. So we then move left or right. And at some point, if we are not in range of the source location, so if we are 7 world units away from the source location, then we change to the state that we want to go back. And here, we need them some logic again. So when we enter that state, I would say we have the idle animation again, I would say. And also in the updates method, if entity in range of the source location, so we can do the same thing here again. So source location and the tolerance here is 0.1, something like that. Then we change back to the rocket idle state. So here we are back to our original source, and then we go back to idle and can detect new enemies and stuff like that. And in here we would need almost the same code as here. No, actually here it's way more simple. We just need something like entity move direction is equal to let's quickly save that. So move component, and the direction is equal to move component direction opposite. And that one we don't have yet, but that one would be rather simple. It's then simply when left, then return right. When right, return left. And otherwise return none. For example, something like this. Do I need to write it like this? Nah. When this, okay, like that. So when he's moving to the left direction, we go right. When he's going to the right direction, we go left. I think that's actually the simplest way to solve that. No need for some calculation with the angle and the source location and stuff like that. We know that here we set the specific direction and he moves to that. At some point, he's too far away from the source location. So he will go back. Hello, Anpa. So let's see if that is either working or crashing our game. So let's go. Okay, so the check when he's back at his source location obviously does not work. Let's make the tolerance here a little bit bigger. Let's see. Nah, he's way too fast on the way back. Or this range check does not work, but why would it not work? What do we check? Ah, that can actually never work. Haha, I get it. Because the source location that we are storing is again the bottom left corner of our entity and not the center. Where do we fix that? I would say in here. So we don't have here the body position copy. We have something else. I want to have a function for that because it seems like we need it many times. So let's call that here sprite. Let's store that. Let's store that here. And whenever you call here center, that then returns the center location. And from that one, that is our source location. That should fix it. And what is center doing? So here in our component, below, the property. So let's have it at the top. So here we have a value center, which is a vector2. Oh, let me think. Which is vector2. Maybe I also want to destructure that. But that one gets a little bit ugly because I want to... Because I also want to update it. So when you call the center function, it needs to update the values because the sprite can be at a different location. So also the center can be at a different location. Then let's make it like this. So we have a value which is called center, which is by default a vector2. And when the get function gets called, what we do is from I don't know what the correct syntax here is for Kotlin. We need to find that out in a moment. So from our fields, the x value is then equal to sprite position or sprite x plus sprite width And from the field, the y is the sprite y plus sprite height. And then return fields. That seems to compile, and I hope it just creates one vector2 instance, and that's it. And I think we can still get the destructuring if we make here an operator function component2, and that one is equal to center. I think that way we can then still destructure the center location. Yeah, let's see if all this theory is working out. So here we have now the center location. So we can move it down like this. We don't need a separate line for that. It's quite short. And now in our game state, this one should now work. So at some point we should be close enough now to the center location. But here we can refactor the code a little bit, which we don't need the sprite at all. So we just need here the center. Which means we don't need that at all, and can write here center x, whoops, center x and center y. Yeah. Good stuff. Then here we also just need the center. I hope that I don't break anything with that introduction here now. And here we also just need the target center, where we can remove now that one. And we can simply pass that here. So that's now a vector2. Okay, so instead of destructuring it, here we can just call center, I think like this. And finally, there is one more function that we can optimize. It's this one here. So that one can be removed. And this one here, that's the target center, which means we can remove this one here. And now we have minus center y and target center x minus center x. Okay. That simplifies certain things, and I hope that it still works. Let's see. Now I would expect that the rocket is returning to its original location, and he's still not stopping. Why? Maybe a little bit more of a tolerance. And if not, we need to debug it in more detail. Yeah. We need to debug it in more detail. How do we do that? Let's say rocket return. Let's make a breakpoint here. So here, what is actually the angle in degrees? So this is a weird number. Huh? Is the value returned? Okay, wait. So this first of all is completely wrong. I expected here completely different values. Let's see. So we get here minus something. Why? We get here the minus 0.3 and we multiply that with this constant. Yeah. So what is the range that this one returns? Returns the angle theta of the polar coordinate r theta that correspond to the rectangular coordinates by computing the arctangent of the value blah blah blah. The returned value is an angle in the range from minus p to p or pi. Do you say pi in English? Minus pi to pi. Minus pi. What is minus pi? Is minus pi on the bottom side of the circle and the positive values are on the top side? Okay, then I would first of all fix that one here. So then this is just the angle 2 methods and we don't multiply here anymore. And we can do the checks a little bit different here. So this is just the angle. And now let's fix that. So if the angle is smaller than, there is a constant for math utils pi. Pi and not half of it, quarter of math pi. We could also extract that as a constant, but for now, let's keep it like that. So it's smaller than this, or it's greater than minus pi. And the other thing would be that it's, let me also write that down differently, that it's greater equals third of a pi or smaller than a quarter of minus pi. No, also greater equal, right? That one we need to check. We keep it like this. Then let's make, again, some debugging sessions. Let's see. Okay, so now we get here a radius of very close to 0. So we will move to the right. And now we have here this breakpoint. So the source location is 1.1 and 7. Does that make sense? Where's our map? So 1.1, yeah, something here that makes sense. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, so it's somewhere very close to the nose of the rocket. So the source location is correct. And what is the... Then let's make a breakpoint in range. So let's go here. What is the center? The center is 8 dot something because we moved to the right. Yes. And the y coordinate is 7. Yes, because we did not move up or down. Okay, but I am questioning this one here. If a number is smaller than 1, you multiply it by itself, the number gets even smaller. But shouldn't it be bigger in our case? Not sure. In my opinion, that one is the problem. So if we check for a tolerance of 2, then we are actually comparing with the value 4 because we don't take the square root of the left side and because it's a slow operation. So that's why we square the right side. But if we have a number smaller than 1, then obviously it gets even smaller when we square it. Do you say square it in English? I'm not sure. When you multiply it with itself, that is what I mean. And I think we don't want that actually. Is it maybe 2 times the right side? That's not correct. So from a mathematical point of view, squaring the right sides of the equation gets rid of the square root on the left side. But I think that is not correct for the, in our case, if we want to have a very accurate comparison. I don't think that that's correct. So maybe let's make a very simple fix here. So if tolerance is smaller than 1, then we return it without squaring it. I just call it square now. And otherwise we square it. Okay, and what else did you say? So I made a mistake here. Smaller equals pi multiplied by because it is close to minus pi. What? Ah, here. Smaller equals. You mean this one here should be smaller equals? Okay. Let's see. So currently we cannot test the... It's still not working. Ha. Let me try now to increase the tolerance to 0.2. Still not working. Screw you, Rockhead. Why are you not behaving the way I want you to behave? I don't get it. Let's debug it again. So again, the center would be currently 8 something, yes, and 7. And the location that we pass is 1 dot something and 7. So that's the source location. So the difference currently is 49. Then I guess now he moved a lot because we had a very huge delta time. No, he actually did not. Ah, because we actually limit the delta time by 1 divided by 30. Let's see. So we step now until we are, when our center is 1.4. So let's see. That would be now not good enough. No! I screwed it up. Fuck it. One more time. Hard to debug stuff like that. Or at least I don't know how to properly debug them in an easier way. So let's go. At some point you are less than 1. Okay, 1.6. That's good enough. So the difference on the y should be 0. Yes, that makes totally sense because we did not move on the y-axis. So that's why there is no difference. So the right part here can be ignored. And the difference on the right side is something smaller. So here actually the same thing applies. So since the difference here is very small, less than 1 world unit, it's minus 0.5, which means multiplied by it is okay. So that one here, in my opinion, is bullshit because the right side, the left side anyway also gets reduced if it's less than 1. So that should be then correct here. But then I would say our tolerance is simply too small. Let's see. Yeah, that's way too small. I would go then for a tolerance of... but let's be honest, that those are world units. So what I want is maybe 0.3, 0.4. Yeah, let's try it with that one. Okay, I have one idea. Let's see. Let's make the tolerance here 0.4 and let's see if that is working. It's never working. One more thing that I want to try is on the way back, let's make him slower. So move component, maximum speed. Equals just 1, for example. So that he's moving back way, way slower. Okay, that's maybe too slow, but now it should be easier to understand. Now it should be easier to understand why he is never in range of the source location. I don't get that. Let's make here some debug lines now. So let's print line here. That result here. And we actually don't need the y value because it's anyway 0. But yeah, keep it for the completeness. And okay. Like this. Let's try it one more time. Okay, distance. Yeah. Ha! I'm completely retarded, it seems like. That's a funny thing. So since the print line is stopping at some point, what does that mean, my friends? That means our check here is actually working and we go back to the idle state. But what don't we do in the idle state? We don't stop the movement. We are idiots. Or what is the state? Rockhead return. We actually forgot to stop his movement. So that's why he's still moving. Haha. Okay, what do we need? Let's go here. Rockhead return. And here he goes back to the idle state. And before he goes back, we set the move direction to none, that he does not move anymore. Eyes are closed, maybe wrong state of entity. Yeah. So now let's try it one more time. Now I'm quite positive. Let's go. Ta-da! Success! Awesome! Let's make him move back a little bit faster. And again. And now he's way too slow. We would also need... Okay, let's remove that one because actually I would need to remember the correct maximum speed to restore it then in another state, which is now something that I don't want to add. So let's move him back as fast as possible. Okay, then we can trigger him again. Okay, so right side movement seems to work. Then we need another womp or rockhead to also test the left movement. So let's just copy our friend and place him over there. Okay, no, let's place him. Let's place him over here. Yeah, because here we could then also test the crushing maybe, not sure. Let's see, now we should have a second rockhead and we hope that he's going to the left, but he's not. He's not going to the left, which means our angle comparison here is garbage. Let's see. The angle is -3. To understand that, what is minus pi minus 3.1 dot something, right? Okay, so that means we set, let me think, multiplied by, that's -2, 3, and -3 is smaller. Yes, but that would mean, isn't that one then true? Yes, that one is true. But obviously something from above is also true. So this one here is false. Ah, I think I get it. I think this check here is not correct. Because a negative number is of course smaller than a very small positive number. Yes, for first, you're right. For first condition, you should also check 0. So what we would need, this one. But then I would say here it's just the AND condition again, right? Isn't the AND condition here the correct way to verify it? Let's see. I think this one still moves right. Yes. And this one now moves left. Yeah. I think that's correct now. With the pi comparison, that should be good enough. At least it seems like it's working. Here we want to replace that again with when statements. I just like them more. Now we also need top and bottom movements. That might be a little bit tricky. Let's move the player over here. And let's make another rockhead here. That one should now go to the bottom. And how do we know that? So the comparison is, we are on the negative side. So we are greater equal this one. And we are also smaller than this one. Is that correct? Let me see. We are. I need real numbers here to think that through. So minus pi by something that's minus, I don't know, 0 something. 3 divided by 4 is less than 1, so something like this. And so we say it needs to be smaller than this number, which is that one, or a negative number which is greater. And minus pi times is equals to, I don't know, minus 2.7. So we say it needs to be between this value and that value. I think that should be correct. So if that's the case, we move to bottom direction, which we don't have yet, but let's add it. Bottom is 2. I hope that also does not break the movement of the player. And opposite stuff. So if bottom, we go top. Okay, then let's also add top, which has a value of 3. Or let's call it down and up. That's a better naming for that. So down would be up, and finally up would be down. And none is equal to none. Okay. That means in here we go down, and let's test that. Also, our move system currently does not support that. So what do we do here? If the direction is not equal to none, then we do something. Entity wants to move right or left. Entity wants to change direction. Yeah. Yeah, so this currently really just assumes a horizontal movement. But we now want to have vertical movement. My idea, so first idea would be to split that maybe into 2 separate systems, but I think we can still combine it. Don't forget you use value from move direction in move system. Yes, I know that this is so. Here we need to think now how to fix that. So current greater 0, maybe when we go up and the direction is left or bottom. I would make it like this. So if direction is left or bottom, and here we have direction is right or top. Yeah. So that one returns this equals left or this equals bottom, down. We need to rename it. Is left or down, and the other function is right or up. So this is right or this is up. Then wants to change direction. Entity wants to move right up or left down. Entity wants to change direction, reset timer to start from slow move speed again. I think that should be the change direction fix. Then flip the sprite to look to the left when the entity wants to move to the left. So if sprite, move direction left. I think that one is unchanged. There we don't care if we're going up or down. There is no flipping necessary. And then it's just the calculation of the speed. Yeah. Okay, then here it wants to have a specific type. We can do that. Okay. Then in the physics system in the update or tick entity, I think it is. So when we update the entity, here we get the move component. Update linear velocity x if entity has a move component. So we just update the velocity completely. If it's a track, then we use this track stuff thingy, and otherwise, oh, here's the track stuff. If it's not a track, then we need to be careful here now. So this is more like if move component direction is right or left, then do this one here, and otherwise body linear velocity x and move component current. That might be it. Not 100% sure, but that might be it. So function is right or left. Right or left. Yeah. Let's see. Theoretically, my player can still move left. Oh no, there is already something broken. The player does not stop anymore. Pooh. So we already broke something. I cannot stop anymore. Why? It should actually still enter in here. But let me check. So player, how did we call that? Input or keyboard? Nah, how did we call that? Keyboard input processor. Current calculated with value from direction. Is that the case? Really? Oh, yes. That's not good. So that's for sure wrong. Wow. What? There's a value. I remember there's a value of, yes, move direction. Then I would keep here. So down would be, is down 1? Maybe. And up is -1. And that one I would call move direction horizontal off. Yeah. Which is called in here in the input controller. Yeah. So hopefully, let's import that and let's call that horizontal direction of. That one should be already the fix for that we multiply with the correct values. But why did the player not stop anymore? So let me think. The move direction would be none. So we would set that here to 0. And finally, in our physics system, we would have here the direction is right or left. Ah, okay. But if it's none, we would never stop. So we have a special case. So if it's none, now none is also actually that case here. That's not the, I think, the coolest way to name a method. But let's see. I think that should fix the player movement again. You can split value to value X and value Y. Ah, yeah, that's even a cleaner solution. Yes, I like it. So first of all, player movement is fixed again. I can stop, which is good. Then bump right movement is still working. Down movement is not working, but that could be... let me think. That could be just this value here. So down is -1 and up is 1. Maybe that's the fix. So now that boy goes down and up. Yeah. So that's also almost working. For whatever reason, he now left the building. What the hell? Why did he went off screen? Maybe we triggered that he should go upwards, and there we are missing the logic currently. Let's see. Let's go back to our game object state, because we have one final thing where we need to set the up movement. Let me think. Do we need to check here anything at all? Because we know that here at that point in time there is an entity in contact range, and we already checked for the right, left, and down area. So the only thing left, so there can only be one direction left, which is that he should move upwards. But I'm a little bit confused. It tells here something that something is always false or true. So that's the down movement. Let's trigger it maybe 4 or 5 times, but that seems to be consistent. Yeah. No. I find that surprising. So when I'm in range, he seems to reach the source location at some point, but when I am not in range anymore, what's the problem? Is this maybe not something related to that? Maybe that's something completely different. So we would return. Wait, he's attacking. Yeah. And when he's not in range anymore, he's going backwards, which would be here. Yeah. And the update function, if he is in range of his source location, then we say move direction none and say stay in the idle state. Okay, let me reproduce that. So for whatever reason, that one is working perfectly, but on his way up, when he has no target anymore, he just flies to space for whatever reason. I don't get it yet. A small typo, horizontal with Z. Is that correct? Ah, yes. Ah, no. Yes, with a Z. Thank you. Then we should split that, right? Value X, let's also fix that because it's cleaner. Value Y. So here we have -1, 0, then 0, 0. Then right is 1, 0, and then we have 0, -1, and 0, 1. Then maybe that one we could call of value x and when value equals 1, then return right. When -1, return left. Then here, I guess we have now some compilation issues. No, then our move system. But yeah, so maybe here again, one more check. Direction is left. Is left or right. Then we multiply with the x value. Otherwise, we multiply with the y value. Like this. Okay. Is left or right? Many if conditions got added in the last couple of minutes. Okay, now what could be the reason that when we leave the sensor that he's no longer reaching his source destination? Can we also reproduce that with the red right and left moving stones? No, it doesn't seem like it. What was going on now? Now that rockhead here also went crazy mode. Okay. I don't get it. To be honest. We are very close to finalizing that guy here, which I like. But something is still not working. So first of all, this warning is irritating me. But I simply ignore it because obviously the left, right, and down movement is working. So this hint, I guess, is just not correct. Yeah, so for me, that is simply not correct. Then I need to debug the state. Let me think. Yes, so let's make here just some print line commands. Return. Wrong stop logic again. Yeah, it could be. So attack would be then attack. Then here we would be in the aggro state. And finally in the idle state. That's it. So let's see. Goes down. And aggro. Oh, we also have this other collision statements. Okay, then go down. And now I move away and he's leaving. What is now the difference? Let's see. So before where it was always working, it was idle, aggro, attack, return. Idle, aggro, attack, return. Idle. So the last state where he was in was idle. How could that be? So here we set the move direction to none. Maybe that one is not working when you go up and down. Let's see. So move system, if the direction is not equal none, we do something. And if it's none, actually I want to write that now differently. I want to have if direction equals move direction none. I hope that still works and should make it a little bit easier to understand. If the direction is none, we don't move it anymore. Ah, yeah. I think I know the problem. And then below, just do some logic. So I think that should now still work, I hope. And our problem is in here again. So if the move direction is right or left or none, then we keep the linear velocity. But actually, we would need to stop it. But I'm not sure if that is correct, because when we are jumping, then we also have a move direction of none, but the gravity should still be applied. So or setting the y velocity would still be correct. So, But anyway, that's for sure our problem here. And it's working. So okay, let me give you my idea. I'm pretty sure that's the issue. Let me. Okay, yeah, movement is still working, but did not break anything. So this one here is working because when he's in the idle state, he detects again that there is something below, and then he just moves to the bottom. So we are setting here the wrong linear velocity. We don't stop him, but due to the attack movement, he's correctly moving down. And when we go away, now we never set the linear velocity y to 0. So that's why he's moving up to space to the whatever the velocity he had before. And how can we now fix that? So we would need to know if an entity just moves right or left. Or maybe more generic case, if let me think. If it should, or if gravity is applied to it. Maybe that's the general rule of thumb. Or the other thing, if it is a dynamic body, then we do this one. And if it's a kinematic body, then we stop it. What would be the best way here to fix that? Or we just do that for the player for now. Currently we had, or before we had the player, we needed this logic and we had track entities. Where's this logic? Now we also have this rocket where we would need this logic, but also something in addition. But we don't want to impact the player. So maybe So this one we want to execute when we are moving right or left or none, which actually means when we are the player. Yeah, but I don't want to link it to the player. I want a general solution. Then what else could we do? We could store here the information about the last direction maybe, which would mean when the current direction is none and the last direction was left or right, then we do this stuff, and if the current direction is none and the last direction was up or down, then we do this one. Yeah. Maybe I'm thinking too complicated right now, but I think at least that is one solution. Let's try that out. So we have here another value or a variable. Our last direction, which is a move direction. And the value is the direction from before. And up here, we would need a special set function. Yes. But how can I set here a setter? Like this looks a little bit ugly since it's part of the constructor. But that would be it. And here we would say last direction equals value, or how is it called? No. I really don't know. What is the correct syntax here? Field. You can't add setter in constructor. I cannot do that. Haha! I can also not move that down there because then the component 1 becomes, for the destructuring, becomes that one here. Then the last direction approach does not help us. That's not good enough. Then let's go to the kinematic and dynamic body approach. So if move component direction equals move direction none, and we don't have the physics body here, right? We have it. And body type equals dynamic body. Then set the linear velocity to 0. But keep the gravity, right? But you can set direction in function. That one would still work. Okay, but let me try first this approach here. So anyway, it's a special case just for direction none. And in here, if it's a dynamic body, we want this one, and otherwise there is no gravity for static and kinematic bodies, so we just stop them immediately. Then here we just have is left or right, and that would be an else. So if the direction is none, we do this one. If it's left or right, we do this one. And otherwise it's up or down. Then we do this one. That should hopefully fix it. So that one is working. And now he's correctly stopping. Okay, that looks good. Then okay, looks good. Then this one here, left, right, also looks good. I like the box 2D collision handling. Yeah, that looks good. So seems like our rockets can finally move in any direction. Yeah. Looks good. So we fixed that one. And yeah, they also are already applying some damage. They are reacting maybe a little bit too fast. So that all of that is currently very ugly. Let's refactor it a little bit. So that stuff here, I don't want it like this. Let's move that to, let's call that update linear velocity and add some comments because I will for sure never remember that again. And invert it. Invert if condition. Yes, then we can do here a return statement and get here rid of the else path, which makes it a little bit nicer. That's the first thing that we can do. And here, entities that follow a track have fixed velocity without any impact for gravity. Okay. Then below here we have move direction is none. Since we have tons of these extension functions, it's not an extension function, normal functions. Let's make another one that we just call is none. Like that. Then we can write here if move direction is none. Then no direction specified. Stop movement. Which means for dynamic bodies, for gravity impacts dynamic bodies, therefore keep current linear velocity of the y-axis. Other bodies have or are not, other bodies are not impacted by gravity. Just stop them. Okay, so here we have this special scenario of the none movement. Then if we are moving horizontally, horizontal movement keeps the gravity value equals linear velocity of the y-axis. Okay, and finally vertical movement. That's a little bit weird. So there is no gravity on the left or right side. So that could basically be 0, to be honest. So we can have it like that. Vertical movement is limited and does not apply a velocity on the x-axis. Okay. Then let's also make that a when statement again. And I think that cleaned that up a little bit. Let's see if it's still working. So moves down. Yes. stops when he's at the top, moves left, moves right, looks good, and let's see, can that guy also move up? Yes, he can. What is maybe a little bit weird that kinematic bodies are moving through the static bodies here. So there is no collision with that, but yeah, we live with that for the time being. Okay, that's good. Too complicated logic. Maybe you should split the system as you told previously. Yeah, with the move system. So here, I think it would be maybe better to split it between horizontal and vertical movement. But since it works for now, we keep it. We made it a little bit better with the early return statements. That makes it a little bit better. And yeah, I think that's it for now. So here, this file, for whatever reason, is broken with syntax highlighting and also with other things. Don't know what is causing that. Then let's also check the AI entity. So here it complains function angle2 is never used, which is also wrong. It is actually used. Let's restart the IDE. Not sure if that solves the problems. But anyway, so we have now kill player when enough force. We don't do that. We simply damage him when he gets in contact. And pushing the player is also working. So that one is good enough for me, I would say. Okay, so now here the highlighting is correct again. And here it still says condition angle is always true when reached. Why is it always true when reached? Because here we say it's smaller than something and greater equal minus pi. If that's not the case, we check if it's greater equals that one or smaller equals that one. And if that's not the case, we check if it's smaller equal than that and greater equal that. But most likely, it must be already greater equal because otherwise that condition here would have triggered. So why this warning is correct logical wise, I still want to keep it because if we move the conditions the other way around, like this, for example, and we would remove that part here, then it would not work anymore. To get rid of the warning, okay, we can simply move that upwards, then it's fine, then it's not complaining. Then let's do it like this and make one final test. And then let's commit all these code changes because that was quite a lot. By the way, also, wait. There are a lot of print lines that we don't want to have anymore. So this one here, this one here. Here was a print line, there was a print line. Anywhere else. So this was the test screen, startup helper. Okay, no, that's good enough. Then let's see, let's try one more time. Goes down. It damaged us. That's good. That one goes now to the right. It goes back. The animations are correctly placed. You can almost jump over them. Maybe they are a little bit too fast. But this is just some number tweaking. Then in the end, the important part is that the logic is working. That seems to be very, very good. Sensors might be a little bit smaller, actually. Yeah. But for today, I'm happy with that. So all of that seems to work, which is great. Then let's commit. So here we had all of that stuff, which is good. Then some graphics, then the AI entity, which got some, the AI entity. Wait. Wasn't there some complaining about duplicated code? No, that is also gone now. Okay. Good. Then animation, there we added the acro state. Yes. Then we had the animation system. Where we added the functionality with the play mode, that it's not looping all the time. That we can also play an animation just once, which is good. Then here we don't need to debug the physics stuff anymore. That's working. Then we added the rockhead game object and fixed the keys in here. What else did we have? So here we refactored the state to an enumeration, which made it easier to set the value in the tiled editor. That's also good. Then here we entered a center value, which gets updated correctly, it seems, with the destructuring. Then what else did we do here? So here we have now this of value x instead of, because we split now between the x and y value with the move direction. Then here we had this move component update, which is also good. The move system update, it's also a little bit better. Physics system is also now a little bit cleaner with an additional contact handling. Yeah, that one also looks good. And finally, the state component, where we fixed it that the initial state, that we did not call the enter method of the initial state. Yep. And finally, an extension method here for the configure state, which we updated, that you can set it, and also that you can have an aggro component for an entity. Looks good. Let's call that add second enemy rocket with 4 direction movement. Okay, I'm pretty sure. Let's see. I think that some of the tests are actually failing now. Or might be failing. Maybe not, which would then also on GitHub then make an error to our action that gets triggered when we commit something to master. But let's see. No, everything is still good. A little bit surprised by that. The move system test. So here I had the test cases for the horizontal movement and stop movement and so on. And seems like they are still working, which is good. I thought maybe we broke something there, but we didn't. Okay, then the last thing for today. That's now the easier part. That was the most complicated one, I would say. And the last thing is now to have some invulnerability effect and to make a sprite blink. And how would we do that? I would say, again, the best way would be some generic solution. So we could add maybe like a blink component with a timer. And maybe the ratio, how fast it should blink. And then a blink system which reacts to that. And then simply when we add the invulnerable component, which we do, I think, in the damage system. Yes. So in here, we maybe add then also the blink component. I think that's the most flexible solution. Where we could also add, for example, a blinking to an entity without invulnerability. I think that makes the most sense. Okay, so one last thing for today, a blink component. And this component, what does it need? It needs a time and maybe a ratio, let's call it like that, which is like the blinks per second. Then maybe let's call it blinks per second. That might make it easier. Let's see. And the last thing would be a timer, which is some internal stuff that we need to make the blink happen. And that's it. Then we need a system, which is an iterating system, and it iterates over all entities which have a blink component and a graphic component. So those two things are necessary. Otherwise, it won't work. And then from our entity, we can get the blink information, where we get the time, the blinks per second, and the timer. The timer needs to be updated, so we for sure need to set it here. And we do that maybe here at the top. So if timer greater equals time, that sounds already very confusing. So let's rename that. That would be the blink time. Blink or maximum blink time or max time. Let's call it max time. Okay, so in here, that one is now called max time. So if the timer is equal to the max time, then we can remove the blink components and return. And also, let me think. Yes, also from the graphic component, we want the sprite, and we always need that. So let's also destructure it here at the top. So we get here the sprite. We don't need this vector 2. And before we stop, we set the alpha value, which would be, is it color? Alpha value equals to 1. I think that means that it's fully visible again. And yeah, so here blinking is over. Blinking is done. Remove it. Otherwise, if we are not done with it, then the timer is we add the delta time to it. And so now we have this blinks per second thingy. How does that help us? Let's think that through. For example, if we want to blink every 10th of a second, maybe we need it differently. Let me think. So the simplest way would be something like this. So if the blink component timer is greater equal the, let's call it something like blink interval, then we simply reset the timer. Also, we would need to reduce the number of blinks to -. And then up there, instead of having a time, we would simply do it by this. So if the amount of blinks is then smaller equals 0, then we stop the blinking. And we could calculate that, how often it should blink, by adding the blink component. And there you say blink for 1.5 seconds and do it every tenth of a second, and with that one we can calculate the amount of blinks. I think that's actually what we want. So differently, we had one component with an additional constructor, yes, like this, and we will use the same approach here again. So what do we actually want to have? So we have the time, how often or how long should it blink, and the blink ratio. Let's call it again the ratio. And that's it. And that one is now calling the, is it with this or how did it work? Yes, with this. Okay, so basically what we are then calling is the normal constructor. And what do we need there? Let me think that now through. We need we just need the timer and the blink interval. And the interval would be the total time divided by the blink ratio. Is that correct? Let's quickly think that through. So let's say the time would be 1 second. And I want that it blinks 8 times. So 1 divided by 8. So every seconds it needs to blink. If it... Okay, but here I set the amount of blinks, right? I want to make it blink 8 times. I would like to pass actually that ratio here, so I don't... I need the time. Yeah, okay, wait. Do I need that? Let me think. So we need... I say here it should blink every 10th of a second for 1 second. So what information do I need in my system? I need this one here. Actually, I just need that what I said before. Wait. Let me revert everything. Let's call that again the blink ratio. We can find a better comment later on. Am I stupid now? Let's see. Maybe I'm stupid. So we said we have here the blink ratio, and when the timer is greater equals the maximum time. That one can never be reached, right? Because if we reset the timer, I get it now. We would maybe, let me think, maybe make that also a variable. Yeah. And swap that around. So if the maximum time is less than 0, then blinking is done, remove it. Okay, that makes sense. Otherwise, we will reduce the maximum time and increase the timer. And if the timer is greater equals the blink ratio. Yeah. Then we reset the timer, and also from the sprites, color alpha is equal to, if sprite color alpha equals 0, then it's 1, and otherwise it's 0. That's it, right? game screen. There we need to add the blink system that it's then working. Let's do that here, right before the rendering is happening. Okay. And finally in our damage system, where we add the invulnerability component, there we also add a blink component. And maximum time would be 1.5 seconds. And let's blink, I don't know, every 1/5 of a second. Okay. So let's make here named arguments to make it more clear. So maximum time equals this one. And the blink ratio is that one. Okay, let's see. That should maybe already work. That's not working at all. Why is it not working? So do we even enter the blink system at all? Let's see. Yes. And now we have this stuff here. So we have this timer, and the timer is greater or equals than the blink ratio. Then at some point we want to enter here. Okay, we are doing that. And alpha is now 1. So if it's 0, we set it to 1. And since it's 1, we set it to 0. Sprite, color, alpha 0. Aha, but maybe the sprite itself did not detect that the color was changed because we are modifying it directly. And maybe that's why it's not rendering properly. Okay, and here it's then stopping. Let's see. Is there a set color? Or how is the draw function actually implemented? So draw texture and then it just passes the vertices. Yes, and the vertices get updated in the set color method. Ah, but there's set alpha. Aha, so that's the one that we need. Okay, that should be easy to fix. We have sprite set alpha. And is there also a sprite get alpha? No. No, that's not available, but that should do the trick. Let's see. Yes, now we are flashing. Shit. We also need to call here set alpha, otherwise we may remain invisible forever. Okay, one more time. I think now that should work properly. I don't know if you see it in the stream, but I can see it that we are blinking. And when it's done, then we stop blinking. Okay, that's maybe not the coolest effects of all. We will also improve that in a future episode where we add some shader logic that actually it's rendered in a white way. So completely white. So the blinking will be most likely, not sure, but we will see this effect. So maybe a white blinking and then it returns back to its original color. But for now that we have some feedback, we have at least this blinking stuff. So 5 times per second. I think this is how we implement it currently. It will blink 5 times per second. Okay, good stuff. That was not so difficult. We did not need the timer here at all. Yeah, we really did not need the timer at all. So we can remove it and that's it. Easy as that. So we had the blink component. Yeah. We had the blink system. Then we had the damage system where we are now adding this blink component. The blink ratio, let's document that. Amount in seconds after a blink is happening. Something like this. And the game screen where we added that. Okay, so add blink effect when player takes damage. Okay, that means for today, I'm surprised because I did not think that we can finish everything in time. Because I thought this rockhead logic might be a tricky one to implement. Initially, I wanted to check something with the forces and that the rockheads don't deal damage at all. I think that would be not that complicated, to be honest, because what we have is a left sensor of the player, a left sensor and a right sensor of the player. We call it, let me check, can I somehow still select them? It's always a little bit tricky. That's the hitbox. Anyway, or is this one inside the... I don't know. One of these should be a sensor for the right side and for the left side. I don't know. Maybe I did not set user data there. But my idea would simply be, as we have seen it today with the contact listener and so on, so we know everything how to achieve that. We would have contact with the left wall sensor of the player because he gets then in contact with a ground body at some point. And if there would be contact with with the hitbox of the rockhead, then we know left side is a wall, right side is a rockhead. So we are in between a wall and a rockhead. Then apply damage or kill the player or whatever. So that would not be that difficult. So everything that you need for that, you have seen it already in the physics system with the contact handling. So currently we just check if the hitboxes are colliding and then we apply some damage. And for that behavior that I just described, there we would need to go in a little bit more detail and somehow remember then the contact entities of the left side of the player and the contact entities on the right side of the player, that we know how to do it, and then just make some logic around that. But in my opinion, what we have now, that's good enough for a little demonstration and demo project where maybe people can look at the code and get something from it. That should be good enough. Okay, so finally, let me see. Did we commit before? Yes, we did. So what we will do tomorrow, because tomorrow there will be another stream, we will do this shader stuff so that the player is blinking in a wide way. Let's do that actually at the beginning. Maybe also play this hurt animation when he's taking damage. And also apply force. Something like that he maybe gets pushed back there a little bit. Then the map boundary, I think, is also something easy. And optimize jumping, let's see. So if there is time left, we can do that. And there we will actually add this logic that I just described. So there we will keep contact of the entities that we are in contact with our foot sensor. And only when we are grounded, so when we can jump off from something, then we can really jump. Because currently we can jump whenever we want. And there we will take this foot sensor into account to know if we can jump or not. Then also this coyote time, I think, is not so difficult to implement. And make the fall velocity cap at a certain value. That should hopefully also not be that difficult. That's a good part for tomorrow. yeah, then it's only just some finalization and beautifications of the game, but that's good enough. One thing that I wanted to try is if the TVM backend is running. Because how to even start it, I think there is a run Gradle task. Because we added the, how was it called, open font thingy from our user interface. And I'm not sure if that is supported by TVM. I remember that there, I think with TrueType fonts and other stuff, there were some problems, so it's simply not supported, not 100% sure. So we might have the problem that our game is not running in the browser, but I wanted to check that. Let's see, so we have now the run task, we should run at the local host, and let's see, were there any errors during the compilation time? Yes. Shared library loader. Free type stuff. Yeah, that is what I thought. So I think the free type font stuff, as I feared, is not working. So those are compiler problems, and that's why the game is simply not starting. A little bit unfortunate, but it is what it is. So that is definitely one downside if you use this free type font instead of the bitmap fonts. And not sure. Most likely I will not fix it anymore, but just that you know it out there. What I mentioned previously in one of, I don't know, 2 or 3 episodes before, you can create a bitmap font with a tool which is called Hiero. Maybe, let me quickly check something. Maybe this Skin Composer can also do that. Dev Skin Composer. Let me see. Can that one... Fonts. And here we have a free type font. Here we could create FNT. I think this is what we would need. Create a new bitmap font. Yeah, so basically we would need a bitmap font instead of a free type font that we have here. Then it will work in the browser because then it's very simple. It's just a texture that gets rendered. And that's it. But the free type font is a little bit more complicated and seems like it's a problem in the browser. I think in our game, the bitmap font would be good enough, so we don't have any benefits at all from the free type font, I would assume. So we might want to change that. Let me take note of that. Change free type font to bitmap font. That's something in addition, if we have time, that we can change that. Test TVM backend again. But currently that's an issue. So currently the free type fonts makes a problem that we cannot run our game in the browser. Okay, but that's it for today. Thank you for watching. Thank you again for your help. And yeah, one thing, last thing that I want to mention. So the move system, in my opinion, it's not so nice because it takes care of too many things, and there are special cases with left, right, top, bottom movement and so on. So we try to combine certain things that should not be combined. And one solution would be to simply split that up. Maybe have a horizontal move component and a vertical move component, and then in tiles make here a property instead of move speed. Maybe that would be a vector or 2 separate values, the speed x and speed y. And depending on that, you add the horizontal or the vertical move speed component. And then we have dedicated logic for the different movements. Right now, we combined the movement of the rocket and the player, which was a little bit inconvenient. I still find it acceptable with the code that we currently have, but especially the special cases here in the physics system, where we have this update linear velocity. So this little method here, which is still quite a few lines of code where we somehow set the linear velocity to different values, that I think could be simplified if we have dedicated components for the different movement behavior. But anyway, this one is good enough for our needs for the time being. And that's it. So again, thanks for watching. Have a nice Sunday and hopefully see each other again tomorrow on Monday, where we implement some fancy little shader. Looking forward to that. That's always cool stuff. I'm not an expert with shader, but I still like it when I see the effect and how it's going on and play a little bit around with it. That's always fun. Okay, then again, have a nice rest of your Sunday and bye-bye.